Question 5b, we have this function that I have no idea what this looks like, and we're going to create we're wondering what's going on at x is equal to 1 when we take a little baby step to the right of 0.01. So if our delta x is 0.01, the question is, what's delta y? How much is y changing? So to find our true delta y, we'd really have to do f of 1.01 minus f of 1. And I don't feel like doing that. I don't feel like plugging 1.01 into this. So what I'm going to do is use differentials. dy is f prime of x times dx. So dx is always the same as delta x. This is 0.01. But I need the derivative, so let's do this. So dy dx, the derivative is going to be the derivative of the first times the second plus the derivative of the second times the first, which is just going to give us 2x ln x plus x. And what I need to do is I need f prime of 1, which is going to give me 2 times the natural log of 1 is 0. So this is just 1 times dx. Okay, so our differential is telling us that our change in y is going to be approximately equal to just 0.01. Okay, for C, we have a similar sort of situation. Our function is y is equal to e to the sine of x. And again, that's tricky. We're looking for the tangent line at x is pi. And what we know is our delta x, right, or dx, is going to be 0.1. So I'm looking for, when this is the change in x, what's the change in y? But I'm going to approximate that using differentials. Right, so here's our equation. So now we need our derivative, right? So our derivative is obviously going to be e to the sine x times cosine x, and we need that derivative at pi. So pi puts us right over here, right at -1, 0. So this is going to be e to the 0, our y value is 0, and our cosine is -1, so that's just -1. So dy then is going to be f prime of pi, which we found, and dx is 0.1, so dy is -0.1, which is a good approximation for the true change in y.